All right, welcome to this Physics 1 Quarter 2 overview assignment. And again, the goal of this assignment is to really help those of you who might be feeling behind in class, want to figure out a way to improve your grade, or some of you who might be really wanting to make sure you earn credit for this quarter 2. So by completing this one activity, again, I'm going to guarantee that you will earn a credit for this class if it is done 100% correctly. Okay, and so what that means is I fully expect you over the next 2 weeks, our last 2 weeks, to ask for help. Okay, please do not sit there and just not do this assignment. I know you can do it, and I know we can do it together if you're feeling uncomfortable with it. So please ask for help or continue watching this video. So this assignment is broken into 3 parts because we had 3 big units, okay? And so I couldn't just blend them all together. And so our first unit was forces, motion, and momentum. And it really was a continuation of our motion unit. So, and that was from quarter 1. So looking at this, here are some important formulas that we're going to need to know. And not necessarily know, but come back to. So when you're looking down below at a question and it's asking for force, you want to look at one of these formulas. If it's looking like, well, how fast did it accelerate? You want to look at one of these. If it's how fast is it going or what's the velocity? You want to look at one of these or momentum. So keeping that in mind, okay, we might be going down to a question and scrolling back up. So our first question here, okay, is a little scenario. And it's a 5-kilogram crate is being pushed to the left. Okay, so the fact that it's being pushed means that there is now a force being applied to it. So using the diagram above, what is the net force acting on the crate? And the best way to calculate a net force is one, right now we just need to focus on the left direction and the right direction. Okay, we're not worried about up and down forces, but theoretically they are there. And so you take the force in the opposite directions, so these two are in opposite directions, and you subtract them. And so whichever direction has more force, so in this case it's going left, that is the direction in which the box is going to move. Okay, so then if we're looking at, okay, force and the net force, okay, again, we can go in here, show our work. We have 10 newtons of force. That's how strong the force is. To the left, I'm just typing it out so we can all be on the same page. And then it's 3, I'm going to do it in a different color. Okay, maybe not. 3 newtons to the right. So then I can do 10 minus 3 will give me 7 newtons of net force to the, which direction had more? Left. So when you go into your answer box, this would be 7 newtons left. Right? So that is an example of our net force. Which force has more? And then a little sneak peek, if they're the same, okay, then you'd have 0 net force. Okay, and so that's important to recognize. Okay, so then now the 5-kilogram crate is being pushed to the left. Okay, so we have 10 newtons again to the left, uh, 3 newtons to the right. We already calculated the net force, so we know that the force actually going left is 7 newtons. So then we want to be able to calculate acceleration. And so to do that, we can use one of these equations. And this one is force divided by mass. So we see that here. And because we know the mass is 5 kilograms and we know the net force, I can calculate the acceleration. And keep in mind, the acceleration units is going to be meters per second per second. So again, you go to show your work. And I answer all of these for us. I wanted to do that first one to get you started on the right foot. But again, so acceleration is going to equal force divided by mass. And your acceleration will be in meters per second per second. Okay, and so that is how fast is it changing velocity as it's being pushed. Okay, so again, we just calculated that from the question above, and this is given to you in this scenario here. Now looking at this, so again, thinking about net force, the crate now is sitting at rest on the floor. And the important part of that is that means all the forces are balanced. Because there's no motion, that means there's a zero net force. And so again, then, if you're looking at this, you have 5 to the left. For it to be perfectly balanced, you would need the same amount going right. And then the same would be true for force going up. And then that means you also know the force going down. So keep that in mind. You know the downward force, even though it's directly set for us. Scenario, okay? The net. If it's sitting at rest, again, we know that. All right, now we're looking at a different scenario where we're looking at this skydiver. So the skydiver has a mass of 50 kilograms. That's going to be important. And we know a downward force. Uh-oh. Hopefully that isn't glitching my camera. And we know the downward force or rate of acceleration, okay, due to gravity is going to be 10 meters per second. So that way we can calculate the weight. Okay, so if I go into this table and calculate the weight, something that's important to know, right? This is a real scenario. Person's weight is not going to change within 10 seconds. Okay, so you calculate the weight once, which again would be 50 times 10 to get you your weight in newtons. And so these will all be the same. Then the other way of talking about weight is downward force, and it says that here. So if your downward force is this strong, and your air resistance, which would actually be acting in the opposite direction, so that would be going up. Okay, and I'll draw this a little bit. Let's draw this. And I'm going to scribble it, so I apologize if it doesn't look very good. Okay, so you have a downward force, which is your weight. That's supposed to be a W. and again, I'm just going to draw a little circle for our person, okay? And then your air resistance is going to be acting in the opposite direction. So can you tell me the net force? And then if you can tell me the net force, we should be able to find the acceleration, because now we know the net force and we know the mass. So again, if I know the force and the mass, I can calculate the acceleration. So we did that here, and again, I got that from right up here. Okay, acceleration equals force divided by mass. So I'll just type that in here for us. Okay. As a reminder, acceleration equals your net force divided by your mass. Again, we know the mass, and you just calculate the net force because these two are going in opposite directions. Okay, so you should be able to fill that table in now. And that leads us to waves. And I'm going to film another video that I will put into this for the waves unit.